Okay, day 2. Number 1. Which of the following best represents the solution of the equation x squared plus 9 equals 0? Very similar to the equation that we saw in day 1. However, if you end up isolating your x squared like we're supposed to, you end up getting this equation, x squared equals negative 9. And that's not a problem to solve. We just still have to take the square root. But you have to know how imaginary numbers work. So you take the square root of both sides, it means x equals positive or negative, don't forget that, square root of negative 9. Now if you try to take the square root of negative 9, say on any sort of standard calculator, it's going to say either error or no solution if it does not deal with complex numbers. And most calculators don't deal with complex numbers. So let's remember a few facts. I is just some number that we're defining as the square root of negative 1. It's called the imaginary unit. And it's how we define every imaginary number. And let's remember one property of square roots. If we take the square root of a product, so if you take the square root of any two things multiplied together, you can actually split that into two separate square roots and then find that product. So here's what we can do. Square root negative 9, let's split it up using this property. Let's just split it up into two of its factors. And I'm going to pick the fact that negative 9 is 9 times negative 1. Now, why did I pick those numbers? Well, I picked the negative 1 because I do know the square root of negative 1. It's this weird number called I. And also, it turns out we do know the square root of 9 is a whole number. Since 9 is a perfect square, its square root is a whole number. And so square root of 9 is saying, well, which number do I need to multiply by itself to give me 9? The answer is 3. Oh, don't forget your positive and negative. And then the square root of negative 1, we're calling I. So there are two solutions to this problem. Positive 3i and negative 3i, which we usually just put that all as one thing and put positive or negative. So the answer is A. And number 2 is another area problem. The length of a rectangle is 5 centimeters more than its width, and they're calling length L and width W. So if the area is 18 centimeters squared, then which of the following must be the length L? We need to highlight some key information. So let me color code this for a sec. So the length L, 5 centimeters more than twice the width. That's a mouthful just to say in plain English. What we need to do is translate that into a math statement. So the length L is, whenever we see is just means is equal to, right? So length is 5 centimeters more than twice the width. What that's saying is twice the width could be represented by 2w, or 2 times w, and it's 5 more than that. So we have to take 2w and increase that value by 5. It's important that the plus 5 comes on the right-hand side, on the end of that. Turns out it really doesn't make a difference in this problem just because of how addition works. But if you're dealing with any sort of negatives, you need to be very careful about those word statements and how you turn those into math statements. Okay, so that's one fact that we know from the problem. And in fact, I'm going to put this whole thing in parentheses, just so that I know length is the entire quantity, the entire thing, 2w plus 5. Okay, area is 18 centimeters. So I can say something like area A equals 18. Well, what else do I know? For any rectangle, area is the length times the width. I know area is 18, so I can substitute. And I get, let me do that over here. Let's start substituting some values. 18 instead of A is equal to, and I have length times width, but instead of writing length, I'm going to write what length is equal to. This entire quantity, 2w plus 5. Because then I'm just multiplying that times w, which is the width. And if you hadn't noticed it already, what we did is we took something that had two different variables in it, and we switched it into an equation with just one variable. So we're only dealing with width an area here. It's very nice. If you multiply out, distribute, and let me put that on the left-hand side just so it looks nicer. You distribute that and you go 2w squared plus, and then it's 5 times w equals 18. That might look like a strange equation to solve if you're not familiar with quadratics, but if you are familiar with quadratics, it's very simple to solve this. It's got a squared term, it's got a linear term, and it does have a constant term. Let's find out the constant term by putting it in standard form. So standard form just means make one side of it equal to 0. So I want this 18 to go away. I need to get rid of the 18, so I need to subtract it. And then the golden rule, whatever you do to one side, you have to do to the other. So the left-hand side is now 2w squared plus 5w minus 18. Notice there were no like terms here, so we can't combine the 18 with the 5. We can't do anything with the 18 and the 2 because those have a w squared and w in them. They're not like terms. So all we can do is really list them out in order, equal to 0. And now we get to the fun part, because there's several different ways to solve this quadratic. We can factor it and find out two solutions. We can try graphing it and see where it crosses the x-axis. Those would be what we call the roots. Those are your two solutions. I could use that humongous quadratic formula. To be honest, you choose your own method. Pick your poison. How's about, let's just graph it. So how do I solve this equation by graphing? If you're looking at a graphing calculator, it's usually in terms of y and x. So we'll make a function called y equals, but instead of putting w, our only variable, we're going to just call that variable x, because the calculator likes to call it x. So y equals 2x squared plus 5x minus 18. Remember that this is a quadratic, so it's going to give you a parabola when you graph it. And to solve this equation, I'm saying, well, when is this function equal to 0? That's the same thing as saying, when is the function, it's the same thing as saying, what are the x-intercepts of the function? Because that's where y is 0, that's the x-intercepts, the x-axis. So these 2 points, if you graph them out and you find the zeros of this function, are the solutions for x, or for, in this case, for width, for w. Now, I'll save the trouble of going through the whole graphing calculator process, or the graphing process, but one solution is at x equals 2. The point 20 is on the graph, in other words. The other point is over here at x equals negative 4.5. So there are two possible solutions for this equation. There's two things you could plug in here that would work, but this is a geometry problem. So any sort of length, width, or area, those values can't be negative. It wouldn't make any sense. So this solution, even though it's valid, we have to reject it in terms of the word problem. Reject this solution. So x is 2, that means w has to be equal to 2. Now, after all that, people would want to pick A. So, oh, I did so much work, I have 2. That's my answer. And that's the trick. Or 2 is your width. 2 is your width, not your length. It's asking for length. But we do know area is length times width. The area is 18, and the width is 2. So plug, and then solve. 18 divided by 2 gives you your length, which is 9. The answer is D.